In this section, I'm going to help build intuition about how kmeans works internally. My goal is to do this through visual understanding. If you're interested in the mathematics, there are many sources available on the web and in print. After that, I will present methods for determining the number of subgroups or clusters if that is not known beforehand. Here is data with two features. I know that the data for this sample is originally from two subgroups. The first step in the kmeans algorithm is to randomly assign each point to one of the two clusters. This is the random aspect of the kmeans algorithm. Cluster 1 is represented by empty green circles and cluster 2 is represented by empty blue triangles. The next step of kmeans is to calculate the centers of each of the two subgroups. The centers of each subgroup is the average position of all the points in that subgroup. The center for each subgroup is shown as the solid green circle and the solid blue triangle for subgroups 1 and 2 respectively. Next, each point in the data is assigned to the cluster of the nearest center. Here you can see that all the points closest to the solid blue triangle center have been assigned to that cluster. The equivalent is true for the other subgroup. This completes one iteration of the kmeans algorithm. The kmeans algorithm will finish when no points change assignment. In this case, many points change cluster assignment, so another iteration will be completed. Here we see the kmeans algorithm after completion of two iterations. New cluster centers have been calculated and each observation has been assigned to the cluster of the nearest center. And here's the algorithm after completion of three iterations. Again, some points have changed cluster assignments, so another iteration of the algorithm will be completed. And this is after completion of the fourth iteration. The algorithm is completed after the fifth iteration. No observations have changed assignment from the end of the fourth to the end of this iteration, so the kmeans algorithm stops. This final point thus shows the cluster assignments for each observation and the cluster centers for each of the two clusters. There are other stopping criteria that you can specify for the kmeans algorithm, such as stopping after some number of iterations or if the cluster centers move less than some distance. Because the kmeans algorithm has a random component, it is run multiple times with the best solution is selected for multiple runs. The kmeans algorithm needs a measurement of model quality to determine the best outcome of multiple runs. Kmeans in R uses the total within cluster sum of squares as that measurement. The kmeans run with the minimum total within cluster sum of squares is considered the best model. Total within cluster sum of squares is easy to calculate. For each cluster in the model and for each observation assigned to that cluster, calculate the squared distance from the observation to the cluster center. This is just the squared Euclidean distance from plane geometry class. Sum all of the squared distance calculated, and that is the total within cluster sum of squares. R does all of this model selection automatically. By specifying instart and kmeans, the algorithm will be run instart times, and the run with the lowest total within cluster sum of squares will be the resulting model. This helps the algorithm find a global minimum instead of a local minimum, but does not guarantee that outcome. In the hands-on exercises, I will show you how to determine the total within cluster sum of squares from the results of running kmeans. Here's a visual example of running the kmeans algorithm on the same data multiple times. In this case, it is known that there are three clusters within the data. The graph on the top right has the lowest within cluster sum of squares. Another item of note, cluster membership is color-coded in these plots. Notice that even between runs that find approximately the same solution, that the cluster memberships are assigned differently. This is not a big deal, just a result of the kmeans algorithm that you should keep in mind. For repeatability, use R's setSeed function before running kmeans to guarantee reproducibility. If you don't know the number of subgroups within the data beforehand, there's a way to heuristically determine the number of clusters. You could use trial and error, but instead the best approach is to run kmeans with 1 through some number of clusters, recording the total within cluster sum of squares for each number of clusters. This is then plotted with the number of clusters on the horizontal axis and the total within cluster sum of squares on the vertical axis. This type of plot is referred to as a scree plot. There may be an elbow in the plotted data, a place where the total within cluster sum of squares decreases much slower with the addition of another cluster. In the plot above, the elbow appears at 2 clusters. This value can then be used to approximate the number of clusters if it is not given or known beforehand. Cool, let's practice what you've learned.